Hey guys, let's take a look at this 718 maximum length of repeated subarray. I've seen this problem before, but I don't remember how I can solve it. I remember just something like dynamic programming. Okay, let's look at the example 1 2 3 2 1 2 3 1 4 7. So the longest common subarray is 3 2 1. So the maximum is 3. So the first one is we have to do it in a brutal way. Just use a loop. So the first we find, like for 1, we find the next start in 1 and then compare. Okay, so for it's I equals 0, I smaller than A, then I plus plus for let J equals 0, J smaller than B dot length. So if they are the same, we can continue, right? Let K equals 0. So while A I plus K equals B I plus K, if they keep the same, K plus equals 1. So okay, let max equals 0. So max equals max K. So finally, we return K max. It's done. It's very simple. But actually, its time limit exceeded. Let's see the result. Oh, sorry. There's a typo here. K should be J. Oh, no, sorry. It should be J. And here is J. Yeah, time limit exceeded. So when the case for all at zeros, we just a0 blah 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 0 blah 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 0 blah blah blah. So it's actually a waste of time. The problem is that we compare too much, like 1 and then compare 2 4. But the next time when we are searching for 2, we also compare 2 4. So this comparison is not necessary. Right? Yeah, for 3, yeah, 3, 2, 2, okay. And if we compare 2 again, there's no need because 2, the common longest string start with 3, 2 is already calculated. 2, 2 will be calculated by 3, 3. This could be done with dynamic programming. Let's look at the formula first. Let's define optimum ij. This is a result equals. So like for this 2 array, what does it mean? It should be max optimum and I j 0 j is to n, right? What do you mean? So n by here must be end with 3, end with 2, end with 1. And optimum end I j equals what? Equals to actually, very simple, equals to optimum end I minus 1 j minus 1 if a when ai equals bj or 0. If that's the same, they cannot be. So we can do this from bottom up. Okay, let's define. Let array matrix result. This is a map. Let map. Okay. new array 8 length map new array b. So this should be a matrix. So for I equals, I still need I smaller than 8 length. For let j equals 0, j smaller than b dot length, j plus plus. That means that if I equals 0, if I equals 0, matrix I j equals AI equals bj. If they are the same, then each 1, if not 0. For j, it's the same. Or j equals 0. Yeah, that's right. So for the other case, matrix I j equals AI equals bj, matrix I minus 1, j minus 1. Yeah, they're already calculated. So if not, 0. So, and then we can at last return matrix I A length B length minus 1. On the code. It's not a constructor. Oh shit. Map. Unexpected 4. Unexpected token. This doesn't work. How could this be possible? My bad. I need to return. Return. Okay. Cannot set operator 0 of them defined. What is this matrix? Array 3, 4. Empty minus 4. Cannot set property 0 undefined. Hi. Field. Array field. I don't remember what the syntax is. Shit. Still. Cannot set property of. What the heck is matrix? Five empty items. It's not empty. Four, 3. See, it's empty times 4. Oh, field. My bad. Why it's empty? D 0. And new array 3. I see. It cannot map. My bad. So matrix equals new array a.length matrix fill for let I equals 0, I smaller than a.length matrix I equals new array b.net. Ah, my God. But the answer is 0. What? Console log matrix. We see shit. We should return max. Still not right. This is 1. Three. And if it's 3 0 2 0 2 0, okay. Now we got 3 1 3. This is 3. This is 1. Because they are the same. So plus 1. Shit. God. Max matrix I j b length minus 1. And it's the same. Cannot read property symbol. Not a number. Okay, let's reduce console log a matrix and matrix a.length reduce return result is 0 result item return max is okay. Max. Shit. Result item return max result. Why is not symmetric? B is the same. So this, or if this one is the same. Ah, hi, yeah. I think there is a max. Let max equals 0. If matrix I j is bigger than max, max equals this one. So we just return max. Oh yay! Yeah, we pass it, so it's much faster now. The key point for this solution is that we cannot just say the last one because last number, because we have to check if they are subarray. They must be consecutive numbers. So we use a matrix, a 2D array, to store the common subarray, which is which ends at the specific indices. And with the same, and we will update the max at the same time. And together with this, we can also just get the string itself. I'm not sure whether it's other solution. This is a dynamic programming. Yeah, it's accepted. It's ONN. Yeah. Space. Yeah, we use the another matrix. Length of AB. Worst cases where all elements are equal. Mean. And yeah. Space complexity. What is the space complexity? This is a brute force. Space complexity is ON. I don't think there is space-time because O1, right? This could be garbage. GC. B stars. What is B stars? Our insight is that in typical cases, most of the time AI is not equal to BJ. We could instead keep a hash map of B starts. Oh, yeah. Such as BJ AI equals hash map. BJ equals AI, and we only loop through those in our J loop. Yeah. So B start should be complexity B. ON. is ON. Empty one, but the ON should be just n numbers, so ON. I see. The last solution, it says a binary search with rolling hash. Rolling hash to store hashes in our set structure. Wow. What? Hash. So are you not done? So the previous one is okay, OMM, mean, OM, yeah. This is mean, yeah. For binary search with naive check. Wow, this is interesting. If there's a K substring common to AB and there's a length J as well, let's check be the answer to question, is there a subarray with length common to A and B? This is a function with a range that must take the form true, 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 false, 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 with at least one true. We can binary search on this function. I don't even understand. Focusing on the binary search, our invariant is that check HI will always be false. We'll start with HI mean clearly check I is false. Now we perform a check in the midpoint, MI low and high, where it is possible. The no I don't understand. If there is a K substring common to AB, then there is a length J smaller KIB as well, yeah. Let's check the answer to the question. Is this subgroup with the length common to A and B? The question was yes, 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 false. Yeah, of course. Focusing on the binary search, our invariant is check high will be always false. Well, we start with high mean. Here, check high is false. Now we perform our check in the midpoint, where it is possible. Then, and when it isn't, as for the check itself, we can even check whether A, I equal B, J, K using set structures. What? Oh, I don't know what. I don't understand. So if this check length, so sin equals a tuple A. Tuple A I. What is I for I for I? J. Ah. It means that I see. It says if there's a K, there must be a K minus 1. So we can just try to approach this K by just binary search. And for each check, we just check all the we just check all the tuples, means the possible subarrays. Yeah. Wow, this is cool. But the comparison maybe takes a lot of time. So time complexity is m plus n times and log. This is the binary search time. M and length of AB. The log factor comes from binary search. The complexity of name check names is yeah, there will be m plus n, yeah. And against will be mean. Space. So for the dynamic programming, the space upspace mn, and time is also mn. Binary search with a rolling hash. I don't know what is going on. Someone said there's only one space is enough. Max is max length of context range. Okay, so max length only depends on max length, so only you need to keep max length, which is one element. You know, below we use max length ending to keep max and traverse the matrix diagonally. These are not someone showing a video. Wow, this guy's accent is so... This guy's accent is so sad. But anyway, I think the dynamic programming approach is best. We have to understand. So that's all for this problem. See you next time.